The network layer, the transport layer, every piece of information, whether it's a flag or data at each layer. Okay? Now, because we're on a switched environment here, the only access or the only packets that we're going to see on this sniffer are either unicast packets directed directly at it, multicast packets that are sent to everyone, but only particular IDs or people running CDP that acknowledge that ID will process those packets, or broadcast traffic. So luckily CDP exists and is transmitted out in multicast, so we're going to see all of those packets. What I've done is I've taken a capture over a period of time of all packets going across that network. I've taken out everything except for CDP packets, because that's the only ones we want to analyze. So when I bring up my sniffer, it's going to show you the CDP packets, and we're going to go down into another window and analyze them further. Let's go ahead and do that now. The particular sniffer software that I'm using here is Ethereal. Now you can use any type you want. Again, they're protocol analyzers and they simply gather in the data. Here we see the data. Let me get you familiar with the fields. The number of the packet, the time since the last packet was transmitted, the source ID. Keep in mind these IDs are at the data link layer. In other words, these are MAC addresses. Now we're going to discuss MAC addresses in another nugget. Suffice it to say that MAC addresses are unique per device. Okay? Now, the destination, this is a MAC address. The exception to the unique MAC address is either a broadcast MAC address, as I talked earlier, there would be all F's here, or a special MAC address for multicast. And here you see the one that is used by Cisco for CDP traffic. We have 01, 00, 0 Charlie, 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 Charlie. This is for CDP only. So anytime you see this in the destination field, you know that the protocol is CDP. Okay, and then it defines it further as Cisco Discovery Protocol. Here's the important part down here. This is the detailed analysis. What we want to pay particular attention to is the information at layer 2, and this is the data link layer, and it's going to tell you IEEE 802.3 Ethernet packet. And the destination address is again that multicast. The source is this MAC address. Then we're going to get into the specifics in the Cisco Discovery Protocol. I'm going to move this window a bit so that we can see that better. Alright, here we're going to have the pieces of information transmitted in that packet. And just like we said, you've got the version, the time to live. This is the hold down time. The default is 180 seconds. You have a checksum. That's simply an algorithm that's run on the packet once you receive it that should match the checksum that's in the packet. If not, it's been altered in transit. Okay, then we get into the more important things, the device ID. R3 is the name of the router that sent this over to R2. If you recall in our diagram, we have the two routers on the network. Alright, so that's the device ID. It gives you a little bit more information there. And then we get into addresses. When we're talking addresses at this area, we're talking about IP addresses. The IP address of router R3 is 192.168.1.3. Then we're going to get into the port ID, Ethernet 0. It's saying out of this port, I am able to send out CDP, and also this can be my SNMP active port. The most information is carried here in the capabilities. Let me scroll down on that. Alright, one more button, and here we have it. Alright. Within the capabilities, it's going to define for you whether this device performs level 3 routing. In other words, is it a router? Yes, it is. And then, our particular device is none of the rest of these things, but it does tell you if it performed layer 2, let me scoot this over, transparent bridging, then this would be a 1. If it performed layer 2 source route bridging, we'd have a 1. Level 2 switching, same thing. Does it receive network layer packets? Yes or no? Does it forward IGMP report packets? This is a new acronym for you, IGMP. It stands for Internet Group Management Protocol. It's simply what is used in the Cisco environment to control multicast and allow for registration of multicast traffic. Alright? And then does it provide level 1 functionality? Let's move back over out of capabilities into the software version. This is actually pretty cool. It's going to tell you the specific version of software running on this iOS device. Now, as I was saying, when you have regular SNMP, you get generic information. You would never have something this granular, or for that matter, this granular, in SNMP in its general MIBs. This specific CDP MIB allows us to pull this information out. It's running version 11.2, maintenance revision 4, and it's running on a 2500 router. And it even gives you more information. The platform is here, and it's going to tell you that this specific platform is a 2509. Not generically a 2500 router, but a 2509. All right, and that is the detailed analysis. What you're going to see above here again is that those packets are sent from, this is router 3, as we defined down here. We saw the particular. So Cisco 9288FB is router 3. From router 3 out to a multicast address. Then we see here from router 2 out to a multicast address. And how do we know it's router 2? We go down into the Cisco Discovery Protocol and we look at the device ID, which is R2. Everything else will be the same as we saw it for R3. And you simply see that repeated. Again with R3, sending out R2, R3, R2, and so on down the line. Sent out every 60 seconds as the timer is set by default. Now, a moment ago, I said everything would be the same. Let me clarify what I mean by that. On R2, I mean the different categories will be the same. In other words, it will have the addresses, the port ID that you see there, the capabilities fields, and all of these here. Now, the actual flag may be different. In fact, it may be that this particular router, R2, is going to support the bridging at level 2, either transparent or source route. Okay, so the flags can be different. I'm just saying that the information fields will be the same, whether it's R3 or R2. In other words, the CDP packet has the same format, regardless of which router it's coming from, or even a switch. All right? Let's move on now into our next category, and that is troubleshooting of CDP. Up here on top, we're going to talk about the commands associated with troubleshooting a router first. All right? So these are the router commands. We have show CDP space, and then we have entry, interface, neighbors, traffic, or simply hitting the enter key as our options after those commands. So if we type in show space CDP and simply hit enter, what we're going to get is the information on the timer of the advertisements and the hold down timer. More of a global sense of what's going on with CDP. Now if we move into our next option, show CDP entry, it's going to ask for a keyword here, and that keyword is going to be the device ID of some neighbor. So if we're on router R3, we would type in here R2, and it's going to give us specific information on this neighbor. So entry gives us neighbor information, and it's designed for a specific neighbor. It also has a wildcard option. If you use the star, it'll give you all neighbors. Okay? Then we move into show CDP interface. What we're going to see here is status and configuration of the interfaces. The status is simply going to tell you whether the interface is up or down, and the configuration is going to give you information about CDP. Really, it's just going to give you the hold down timer and the advertisement timer. All right, show CDP neighbors. This is going to give us a quick reference checklist of all the neighbors. It's not going to be in the same format that you would find here if you use the star command. It's going to have device ID, platform, things of that sort listed across the page, and it's going to list the neighbors in this order here. Okay, next, show CDP traffic. This is going to show you statistics. The statistics that it gives you is packets in the router, packets going out of the router, and then a number of errors. And the errors are going to show in categories as we type in this command and hit enter. Let's try each of these commands now on our router. Let me gain access. Password there. Move up with the enable command, password at the privilege level, and here I am. Now we're going to illustrate our show CDP command. The first one we just hit enter. As I said before, you're going to see the different timer intervals. This is the time for advertisements, and this is the hold down time. Alright, next we're going to show CDP, then we're going to type in entry, and after that it's going to ask for a keyword. Now if we type in R1, which is a router that does not exist on this network, this is all you get. It gives you another prompt. It doesn't tell you or alert you that, hey, that's not one of the neighbors. Just be aware of that. Now, if we type that command in with one of the neighbors, like R2, that actually exists, here's the information. The device ID, the IP address, the platform.